Our universe is a symphony of motion. Planets orbit stars, stars cluster into galaxies. Even at the smallest level, atoms vibrate with restless energy. This is the clockwork universe, governed by the laws of physics. But what if I told you that scientists have discovered something that seems to defy these laws, something that challenges our very understanding of time itself? This is the story of time crystals. Imagine a crystal, its atoms arranged in a repeating pattern. Now imagine this pattern, not in space, but in time. This is a time crystal, a new form of matter that pulsates in a regular rhythm, endlessly, without any external energy source. It's like a clock that never needs winding, a perpetual motion machine permitted by the strange laws of quantum mechanics. Imagine a material that defies the very laws of physics. It never runs out of energy. It's constantly moving, oscillating back and forth, without using any energy at all. Sounds impossible, right? But welcome to the strange and fascinating world of time crystals. We are familiar with crystals like salt and diamonds. Okay, so what exactly is a time crystal? In regular matter like diamonds, quartz, or even snowflakes, atoms are arranged in a repeating pattern in space. But time crystals? They have a structure that repeats in time. Their atoms are arranged in a fixed, repeating pattern in space. This repeating structure gives crystals their unique properties like their shape and hardness. Time crystals, however, take this concept to a whole new dimension. Their atoms are arranged in a pattern that repeats not just in space but in time as well. Imagine a ring of atoms. In a normal crystal, these atoms would be stationary, locked in their positions. But in a time crystal, these atoms would constantly cycle through a series of configurations, returning to their original arrangement after a precise period of time. This rhythmic dance continues indefinitely, without any external push. This is the essence of a time crystal, a stable repeating pattern in time. The concept of time crystals seems paradoxical. How can something move perpetually without any energy input? The answer lies in the bizarre world of quantum mechanics. Here's the kicker. Time crystals oscillate between states in perfect harmony, but they don't lose energy. They keep moving like a pendulum swinging forever without running down. And this completely breaks one of the fundamental laws of physics, thermodynamics. In the quantum realm, the classical laws of physics don't always apply. Particles can exist in multiple states at once, and energy can fluctuate in unpredictable ways. Time crystals exploit these quantum quirks. They exist in a state of perpetual motion, not because they are defying the laws of physics, but because they are operating under a different set of rules. These rules allow them to break a fundamental symmetry of nature-time translation symmetry. This means that the laws of physics are the same at all times. However, time crystals violate this symmetry by exhibiting different properties at different points in their cycle. The idea of a perpetual motion machine has always fascinated and frustrated scientists. The laws of thermodynamics, which govern energy transfer and transformation, seem to forbid the existence of such a device. The first law states that energy cannot be created or destroyed, only converted from one form to another. The second law tells us that, in any energy conversion, some energy is always lost as unusable heat, increasing the entropy or disorder of the universe. Time crystals, however, don't violate these laws. They are not creating energy out of thin air, nor are they performing work without any energy input. Instead, they exist in a low-energy state, protected by the principles of quantum mechanics. Their perpetual motion is a consequence of their unique quantum properties, not a violation of fundamental physical laws. Section 5. Quantum entanglement, the secret sauce of time crystals. One of the key ingredients in the recipe for a time crystal is quantum entanglement. This bizarre phenomenon, which Einstein famously called spooky action at a distance, allows two or more particles to become linked, even if they are separated by vast distances. Any change to one entangled particle instantly affects the others, regardless of the distance between them. In a time crystal, the atoms are entangled with each other. This entanglement creates a collective state where the atoms are constantly exchanging energy and information. This constant exchange allows the time crystal to maintain its stable, repeating pattern without any external energy source. The entanglement ensures that the atoms remain synchronized, even as they cycle through their different configurations. So where did this concept even come from? The idea of time crystals was first proposed in 2012 by none other than Nobel Prize-winning physicist Frank Wilczek. He suggested that, under the right conditions, it might be possible for certain systems to exhibit motion in their lowest energy state, without any external energy. And in 2016, it wasn't just an idea anymore. Scientists at the University of Maryland and Harvard managed to create the first real-time crystal using trapped ions and laser pulses. This was a groundbreaking moment because it proved that this new phase of matter, something beyond our traditional understanding, actually existed. Section 6. Frank Wilczek's vision, from theory to reality. The concept of time crystals first emerged from the mind of Frank Wilczek, a Nobel laureate in physics. In 2012, he was pondering the nature of crystals and their repeating patterns in space. He wondered if a similar phenomenon could exist in time, a system that could break time translation symmetry. His calculations suggested that such a system was indeed possible. Wilczek's idea initially met with skepticism. Many physicists doubted that such a bizarre state of matter could actually exist. However, his work sparked a flurry of research, with scientists around the world racing to create a time crystal in the lab. The race was on to turn this theoretical curiosity into a tangible reality. Section 7. The birth of a time crystal, from ions to electrons. The first experimental evidence of a time crystal emerged in 2016. Two independent teams, one at the University of Maryland and the other at Harvard University, created time crystals using different approaches. The Maryland group used a chain of ytterbium ions, while the Harvard team used nitrogen vacancy centers in diamonds. Both experiments involved trapping particles and manipulating them with lasers and microwaves. By carefully controlling the interactions between the particles, the researchers were able to induce a stable, repeating pattern in their behavior. This pattern persisted even after the initial energy pulse, a clear indication of a time crystal. Section 8. Quantum computing's new ally, time crystals on the horizon. The discovery of time crystals has sent ripples of excitement through the scientific community, particularly in the field of quantum computing. Quantum computers, which harness the strange laws of quantum mechanics to perform calculations, have the potential to revolutionize fields like medicine, materials science, and artificial intelligence. However, building a practical quantum computer is a daunting task, plagued by challenges like decoherence, where quantum information is lost to the environment. Time crystals, with their inherent stability and resistance to external perturbations, could offer a solution. Their ability to maintain a coherent quantum state for extended periods could be harnessed to build more robust and reliable quantum memories, a crucial component of future quantum computers. Researchers are exploring ways to integrate time crystals into quantum computing architectures, paving the way for a new generation of powerful quantum devices. Section 9. Storing energy in time's fabric. A glimpse into the future. The unique properties of time crystals extend beyond quantum computing. Their ability to store energy in a stable, oscillating state has sparked interest in their potential for energy storage. Imagine a battery that never runs out, powered by the perpetual motion of a time crystal. While this might sound like science fiction, researchers are exploring the feasibility of using time crystals to develop new energy storage technologies. The challenges are significant. Currently, the amount of energy stored in a time crystal is minuscule, far too small for any practical applications. However, as our understanding of time crystals deepens and we develop new techniques to manipulate them, the possibility of harnessing their energy storage potential becomes less remote. Time crystals could one day power our devices and even our cities, ushering in a new era of sustainable energy. Section 10. The mysteries remain. Unanswered questions and unexplored territories. The discovery of time crystals has opened up a new frontier in physics, revealing a universe stranger and more wondrous than we ever imagined. However, with every answer, new questions emerge. We are still in the early days of understanding these enigmatic entities. How do time crystals form? What are their fundamental limits? Can we manipulate their properties to suit our needs? These are just a few of the mysteries that lie ahead. As we delve deeper into the realm of time crystals, we can expect to uncover even more surprises, challenging our assumptions about the nature of time, matter, and the very fabric of reality. The journey has just begun. Section 11. Time crystals, a testament to the universe's infinite wonders. The discovery of time crystals is a testament to the power of human curiosity and our relentless pursuit of knowledge. It reminds us that the universe is full of surprises, waiting to be uncovered. These strange crystals, ticking away in their own quantum rhythm, challenge our understanding of the universe and hint at the vast, unexplored territories that lie beyond the horizon of our current knowledge. As we continue to unravel the secrets of time crystals, we can expect to make groundbreaking discoveries that will transform our understanding of the universe and our place within it. This is an exciting time to be a scientist, an exhilarating time to be alive. The universe is full of wonders, and time crystals are just the beginning dot. If this blew your mind, hit that like button, subscribe to Sci-Mind Machine YT, and dive deeper with us into the wildest science you've never imagined.